Good afternoon, everybody. My name is Ian Campbell. I'm Vice President of Operations at PASIC and serve as staff support for PASIC's Risk Management Advisory Committee and for the corporation's Risk Officers Forum. I'm also your moderator for today's webinar, in which we explore risk issues related to the Smart Factory, innovative new technologies affecting P&C insurance in Canada. This is the second of 3 emerging risks webinars that we're hosting this year. We'll use these sessions to drill deeper into topical issues that have caught the attention of risk management professionals and other stakeholders throughout the industry. Our webinars offer a convenient means to bring together interested parties from across Canada who might not otherwise be available to attend regularly scheduled Risk Officers Forum meetings in Toronto. Interest in our webinar series continues to grow. We have senior risk officers from 40 organizations across Canada joining us here today. Great to have you with us. A special welcome if this is your first time participating in a PASIC Emerging Risks webinar. We hope that you'll find the next 90 minutes very informative, and we thank you for joining the call. I wanted to briefly review with you a few housekeeping items before moving on to introduce our guest speaker. The first regards antitrust compliance. Members are advised that under the Competition Act, they cannot collude on their approaches to any business strategies. The Competition Act applies at all times. You are and remain industry competitors. Commentary cannot reveal directly or indirectly individual claims adjusting practices, approaches to determining the scope of coverage or resolving mixed claims, or common practices in managing third-party vendors and service providers. My second point concerns the recording of this webinar. We routinely record all of our webinar sessions for future on-demand rebroadcast. A copy of today's presentation will appear on PASIC's website shortly. This will be of interest to some of our members who are not able to join us here today. Next is a standard disclaimer to keep our lawyers happy. While we greatly appreciate having industry specialists as our guest speakers to lead our webinar presentations, please note that the views and opinions expressed by our guest speaker and any viewers providing questions and commentary do not necessarily represent the views and/or positions of PASIC's Risk Management Advisory Committee or the corporation. And the final housekeeping item concerns viewer feedback. Our webinars are designed to be very informative, collegial, and interactive. We invite your questions and comments throughout the presentation. If past webinars are any indication, there will likely be lots of questions coming forward as we move through the slides. And you'll find a question box on the bottom of your screen, which we invite you to use, and that will only be viewed by me. We want today's webinar to be conversational and thought-provoking. All feedback is received in strict confidence. Your name and organization will not appear on viewer screens, only mine. I'll pose the questions to our speaker as they're received. Please feel comfortable sharing your thoughts with us. The advantage of you tuning in live is that you can help to guide discussion in real time. That concludes my list of housekeeping items. It's now my pleasure to introduce our guest speaker for this afternoon's webinar, Luke Watts. Luke is joining us from the UK. He joined RSA Group's Enterprise Risk Management team in 2015 with responsibility for emerging risk analysis, risk appetite, and risk committee reporting. He has more than 15 years of risk management experience, and his varied career has included risk roles at both Aviva and Barclays. Having liaised with most functional areas within these organizations, Luke has a diverse perspective on the risks that underpin an insurer. He's an active member of the Emerging Risk Initiative run by the CRO Forum in Europe. He has a keen interest in innovation and will seek to lead a thought-provoking webinar on the Smart Factory with insights gained into this year's main topic, autonomous machines. Luke will be speaking with us today about the Smart Factory. You'll recall seeing mention of this term in the background materials for this webinar. It was noted that the world is about to embark on a fourth industrial revolution, propelled by innovative technologies termed the Smart Factory. The world's becoming a giant information system with new business models affecting supply chains, transportation systems, and labor skills. While the Smart Factory is still in its infancy, it's clear that the interdependence of business processes and the reliance on information will present significant challenges in the year ahead. Luke will explain this concept to us in greater detail and provide us with helpful insight from a risk management perspective. I'll now hand things over to Luke and rejoin the conversation from time to time with your questions and comments. Welcome, Luke, and over to you.
Great, thanks, Ian. Thank you for a very good introduction, and very kind of you to ask me to join you and give this presentation today. And thank you very much for all of those of you that are attending. It's a pleasure to be here. It's a shame I'm not on Canadian soil myself, but it's very rainy here in London today. But yeah, it's a pleasure to be talking to you today, and I hope to be able to deliver an insightful presentation to you on the smart factory. A few things I just want to be, a few legals for me, just want to be clear on a couple of points, I guess. I'm representing the CRO Forum today and the work that was produced by the CRO Forum in developing the smart factory paper published in 2015, but it probably ought to say that these are my views in the presentation, and so whilst I'm representing them, there may be some views in here which are specific to myself. I'm also an RSA employee, and today, as I'm representing the CRO Forum, I'm not really representing the organisation. And again, the views are my own views and not those shared by the organisation. Finally, a very quick point: I'm not really a technologist, and I'm not an insurance risk specialist. So whilst I'm very interested in innovation, I've been following innovation for a number of years now, and I'm hoping that today I'll be able to provide you an insightful presentation. If there are very technical questions, then that may be beyond my skill set. But let's see how we go. The intention of the slides today is to first of all take you through the key concepts of the smart factory. The smart factory is a really interesting space because there are so many converging technologies coming into play at this point that what I really want to do is spend half the presentation going through those technologies, outlining how they impact on the smart factory and how they're going to revolutionize our lives. And then I'm going to spend the rest of the presentation thinking about what that means from a risk perspective and what that means for the insurance sector as well. Obviously, as a UK specialist, there may be times when I'm not able to represent Canadian insurance market as effectively as somebody from your own market, but I have tried to take that into consideration when I pull this together, and I'd be interested in any questions or views that people have that are specific to the Canadian market. I feel like I've done a few caveats. My last one is the slides are quite heavy, but I do, this is a relatively long presentation. There is quite a lot to cover within this topic, so I don't really apologise for the heavy slides, but I'm not expecting you to necessarily read every page, and I will talk through them, and hopefully they provide the insights you're looking for. Anyway,
I should just note, sorry, Luke, I should just note that a copy of your slides will be made available to all members after the presentation. So thank you for that.
Excellent, thank you. Right, so going straight into the subject then. My first point is just to introduce the CRO Forum. So the CRO Forum is a collection of major European insurers representing the CROs themselves, and they aim to champion best practice within the risk function as well itself, but also to look at emerging risks and consider some of the key insights. And as part of that CRO Forum, they create a number of sub-working groups, of which the Emerging Risk Initiative was the first of those subgroups. There are other subgroups on topics like data protection, cyber. So there's a number of different working groups that are driving the CRO initiatives. So the Emerging Risk Initiative itself is there to both look at best practice around emerging risk and how we're approaching emerging risk, but also to analyse and explore some of the key topics that are considered emerging risks, and also to maintain an emerging risk radar, so a hotspot of some of the key topics that seem to be present in the market. And I guess when we talk about emerging risk, it's probably worth just articulating what we mean by that. We mean any risks where the outcomes of that risk may not be quite clear, or the risk itself is currently emerging. So the implications for us as a sector may not be particularly clear at this point. The technology is definitely one of the key features that appear in the emerging risk radar. So the other thing that we do is, so we produce the emerging risk radar once a year. We also produce 1 or 2 papers each year. Last year's paper was on water risk, and the year before that was a smart factory, hence the conversation today. This year we are looking at autonomous machines and the implications that may have. Okay, so in terms of the smart factory, I just wanted to outline this term, the fourth revolution. So smart factory and fourth revolution are two terms which I think are used interchangeably, really. The smart factory is a term that was coined by the Germans. They're investing heavily, as you'll see on the next slide, in the smart factory, and it was them who sort of like coined that actual topic. In terms of the fourth revolution, we talked. The first revolution was water and steam, so powering machines. The second revolution was electricity. The third revolution was then around automation, and we come into the fourth one, which is talking about cyber physical systems. Now, I do have a view on this fourth revolution. I'm not convinced it's a fourth revolution. I think this is probably an extension of the third revolution, because it's really driven by computing and computing power. So maybe we could class this as 3.9, but hey, why split hairs on that one? And I guess when we talk about the smart factory, helping to visualize this, what we're talking about is maybe producing something without any real human interaction, and that could be starting very much from the supply chain, the mines that are out there, right the way through to the supply to the customer. Whether we'll get to that stage and that full level of automation, we'll see. But that is the the view of what's possible. The other that's a key feature in this is, and it's touched on in the diagram here, is customer intimacy and personalization, and the fact that somebody could make an order, that order could then be processed in real time, and the tooling of that factory effectively changed to deal with that personalization. So quite a dynamic and customer intimate process could be enabled through the use of smart factories. As I mentioned, the term is coined by the Germans. There was 40 billion invested every year until 2020, so a considerable investment from themselves. Most of that is aiming to introduce standardization and support the whole sector. So standardization is going to be a key to making this work. One organization trying to build their own capability is probably not going to get to the level that is feasible and possible. The scale and speed of which change is going to happen isn't yet clear. Again, it's a place where people are talking a lot about what is possible. It'll be interesting to see how quickly the technology can get there, and later on in the presentation I'll flag up some of the potential limitations to that. In terms of risk challenges, I guess the key three ones I would pull out, and there are more than this, and again I'll touch on this later, but determining the liability of loss. So if we talk about the smart factory, the number of people that are actually going to be interactive and touching a process, or the number of companies that are supporting that process, is becoming more diverse. So identifying where the liability of loss falls may become more complicated. It's a similar concept discussed around autonomous vehicles. Securing data and cyber attacks is obviously another key concern, and given the weekend that we've just had, I'm not sure how much Canada was impacted, but as you may have heard, the UK NHS system was heavily impacted by the cyber attack over the weekend. These kind of attacks are going to continue to permeate the different markets.
It was an issue here as well. So
great, yeah, okay. And then business interruption risk and supply chain problems. So in theory, automation should help to reduce outages. That's one of the aims, and should introduce more advanced just-in-time technologies that enable the supply chain to support manufacturing much more efficiently. But with that efficiency, if there are any challenges in that supply chain, then the impact that could have could be quite severe further on down the line. So I'll touch on that point again later on, but I think that's quite a key point. The key for reinsurers and insurers is really to understand the changing loss patterns. So what does that mean for us if we're having less injuries, if products can be produced to a better specification and better level of quality? Does that reduce product liability requirements? So so it's really understanding those changing patterns, and again I'll touch on that later in the presentation. So what I'm going to do now is then talk through what I class as some of the key enablers for the smart factory. The first of these I've termed robotics. Now, I don't really see robotics as being a key part of the smart factory. Robotics have been here for many years, and manufacturing, especially in automotive manufacturing, has used robots and continue to use robots extensively. So I don't really see this as one of the primary enablers, but it is a very important factor. The use of robots continues to grow substantially, and I think it's interesting, the stat from the World Robotics organization where they say the Republic of Korea has 521 robots to every 10,000. That's quite a surprising number, and I did have to look this up, by the way. The Republic of Korea is South Korea. So the use of robots is dramatically increasing, and I don't see that changing in the short term. But what does enable the smart factory, and what is key, is really the autonomous robots. So, if we talk about logistics, having autonomous vehicles, and there's some quite advanced uses of this. We've got a diagram here from BMW where they're using it in the plant in Germany. We see that in other plants, but there's also a mine in Australia where they're now using the huge, massive machine earth moving equipment is all now autonomous, and that's running from the point of mining through to the point of dumping for onward distribution, and that is a fully autonomous system with no drivers in the cab. So it is already happening and is out there. I mean, that's quite a specific case, and it's a relatively low risk environment because you are talking about a very remote environment where and a quite a harsh environment, so there's not an awful lot of surprising threats to that the autonomous machines. So it works well in that environment, but it does highlight what's already possible. Autonomous production lines, so running themselves with very little human interaction. Autonomous maintenance, so the plant monitoring maintenance requirements and fixing those maintenance issues on an as needs basis, but also pre-planned. And then what I've been calling beyond just in time, and what I mean by that is, just in time technology was making sure that the supply chain was providing the plant the materials to you as soon as you need it. There's a car plant in the UK in Swindon where the body parts are supplied from Birmingham, another city which is 2 hours away, and the supply chain there is every 1 hour. So if there's a problem on one of the motorways in the UK, that can stop production, and that doesn't need to be that major an event either. So just in time is going to make that even more efficient. The monitoring of where those parts are, and altering production to fit in with the supply chain will be possible. So the other enabler I'm going to move on to is the smart sensors. Now, when I talk about maintenance, smart sensors is a huge enabler for that. And by sensors, we're talking about maybe traditional sensors that you would see on a plant, but maybe also audio and video sensors. So cameras that monitor the flow of production, or microphones that can listen into particular machines and pick up maybe particular noises. So if a bearing starts to go, that can be quite noisy. So the microphone could be able to pick up very small changes in the sound that's coming from that bearing and alert someone to that case. And that enables you to plan the maintenance of that part of the system. So smart sensors is going to make quite a significant change, but it can also change things like security, and it can change things in terms of health and safety to enable the robots to understand if humans are around them, and maybe to alter how they operate. I mean, I think there's loads of different ways of looking at this technology, but for instance, maybe a factory doesn't have any humans in it at all, and it runs at a very high speed because it can do so without risk of injury. And then as soon as visitors arrive or there are humans that are present within the factory, maybe it automatically slows down. That may not happen, but it's thinking about what is possible. So the other thing, because they're smart, they can obviously be monitored off-site, and they can be adjusted to look at different things remotely, and they can inform the intelligent systems. So one of the examples I've got here is around motors, and one of the motor companies is already fitting smart monitors that enables you to monitor millions of motors and do predictive maintenance on those motors from a single location. Next enabler is collaborative machines, or the Internet of Things. The Internet of Things is a topic which gets used an awful lot. What I guess we're really talking about here is machine-to-machine communications. So you could have a factory in Australia, and you could potentially control that factory from the UK, and all of the machines within that factory could be communicating to each other. But you could also have communication between the factory and autonomous machines supplying it and autonomous machines delivering it. There's another interesting factor, I think, in Internet of Things, which is potentially you could have a product, say a car, which is actually communicating directly back to the factory. So, for instance, maybe the brake wear is particularly heavy on a particular vehicle, and maybe autonomously you could review why that's happening, make a judgment about maybe the weight distribution of that vehicle, make slight adjustments to the manufacturing, and change the manufacturing plant and put that straight through into the manufacturing plant in an autonomous way. Again, really advanced topic there. I'm not saying that's going to happen in the next few years, but you know, again, it's that art of the possible. I do like the brewing topic here, where they're talking about using monitors that actually help the craft brewing process, and so like monitor the inner workings. So yeah, even craft breweries are thinking about how we can automate and how Internet of Things can support us. I do see this as the main enabler and the thing that creates the Industrial Revolution 4.0. However, there is sort of like the downside of that in the fact that this is the thing that opens us up to cyber threats. So whenever you have something connecting between sites, that does create a weakness, which can be utilized by others, and that could be criminals wanting for ransom, for instance, or it could be industrial espionage as well. I mean, you know, we'll touch on cyber risk in a little bit later, but imagine an environment where actually one of your competitors can hack into your factory and introduce a very small defect, which will create quite a few product issues further on down the line. You know, that's I guess that would be possible. You hope people wouldn't do that, but there we go. Two other technologies that I would like to just pick up on is augmented reality. There are some that argue augmented reality would be one of the enablers. I haven't included that as so, but you know, what I wanted to highlight through augmented reality is maybe the visualization that can be taken. So if you've got sensors so that are audio and video, the augmented reality headsets could use that to monitor factories from some distance and give the operator a very real experience. Could also be utilized for things like maintenance, where maybe you could go in and actually operate a robot from a remote site and inspect damage and make the changes or the maintenance work remotely. Another one that was flagged, you know, I was distributing a slide around to get some feedback from other specialists. One of the ones that was flagged was blockchain. Again, you know, blockchain is a topic that gets talked about a lot. Blockchain is a piece of technology that really creates a smart ledger. It's one that supports digital currencies, and that's where it was invented for digital currencies. But it's now being considered in terms of how it supports other industries. And one of the ways I think it could support smart factory is either through the supply chain or with customers, where high volumes of data could be shared equally between the manufacturer and the supplier in a secure manner. So again, I think in terms of enabling the smart factory, it is definitely an enabler, but I don't see it as one of the key ones I wanted to cover today. Is there any questions, Ian?
No questions yet, but certainly a good chance to ask everybody. If you have any questions up to this point, fire them in, and I'll pose them to Luke. But nothing received yet.
Okay, great, thank you. The next one is big data. Again, big data is one of those phrases that gets used a lot as well. The key thing here is the analytics and data analytics. You know, I think that the quote at the bottom of the slide is a quite an insightful quote from Rolls-Royce, where they talk about 3 petabytes of data on manufacturing just one component, and that's in the manufacturing they're doing today. Analyzing all of that data, being able to make judgments off that data is going to be a key challenge, I think, moving forward. But it also a key enabler. You know, I talked about getting real-time feedback from a car with maybe with high brake wear, that is it is possible and is achievable. But also monitoring manufacturing and being able to alter manufacturing to enable the most energy efficient process could be supported through the analysis of the data coming back from the plants. The preemptive maintenance examples that I talked about earlier, that relies on analysing the data and being able to pick up on trends that are happening. In terms of customer service through product enhancements and individualization, that could also be done through big data and how products are actually being used. Big data is a big topic. It's the analytics that gives you that competitive advantage. The next one is artificial intelligence. This is probably the biggest area that we're going to cover. Artificial intelligence, true artificial intelligence, I do believe is some way off. What we are really talking about is cognitive computing. So we've got the big data, we've got the analytics. The cognitive computing is then really making the decisions and the judgments off those in an automated way and altering an outcome as a consequence of that. I really prefer to think of it as programmable decision making when people talk about artificial intelligence. So what I mean by that is using the data to help change those decisions. So it relies on a set of algorithms to make any decision. The way in which the data feeds into those algorithms helps that maybe causes a different outcome, but also the data that appears may also change the algorithm that's used. So if you've got a series of algorithms, there could be quite a range of different outcomes that could be achieved by that computer in the way it processes that data and the choices it makes in terms of which algorithm to use for which situation. So I hope that's not. I hope that's a relatively simplistic view, but basically what we're talking about is advanced decision making by a computer, but in a programmed way. I think that, true artificial intelligence is taking that onto the next level where it's able to really think for itself. But what does this enable? I think if we take something like metal extrusion and trying to extrude a piece of metal. The speed at which you do that extrusion changes for every raw material, because as in everything in nature, nothing is consistent and the same. So you do need to vary the speed at which you extrude metal based on the properties of each run or each supplied piece of metal. So being able to do that in real time is something that could be used. Bread baking also relies on the level of gluten. Anybody here that's a baker of bread will understand that the water you add to your flour varies each time. That's based on the gluten. So again, being able to sense the gluten levels and alter recipes in real time is something that could be achieved. Supply chain. So again, if there are any issues or incidents happening in supply chain, cognitive computing would allow the plant to actually maybe alter its approach. So maybe there's a particular leather which it can't be supplied for a seat to go into a car. Well, then maybe the production the computer decides that it'll start producing a different run of vehicles, so it's not held up by that particular supply chain issue. Again, those kind of decisions would be possible. Demand, so changing production based on the demand figures that are coming through from the customer, and also environmental factors. So whether there's people present, some production lines are quite dependent on ambient temperature and moisture levels. So again, maybe making judgments for that. So artificial intelligence can really make a big jump. I think I like the quote on the right hand side from the engineers are training Watson quote, because what that highlights is that actually, some of the ways that artificial intelligence or cognitive computing is being used now is actually to help operatives and inform their decision making. So it's not actually making the decisions itself, they're supplying the data back to that person. I also understand that's happening in medicine. So a doctor can try and diagnose a patient, and the artificial intelligence works alongside them to say, to help them maybe get to the options quicker and explore and alter their questions based on the responses they're getting back from the patient. 3D printing, I think this is my final enabler. 3D printing I don't really see as a production, I see as a production technique, not really a enabler in quite the same way as the other technologies. But without 3D printing, the flexibility of production and being able to produce quite a range of different products in a short space of time isn't going to be possible. So 3D printing really moves the flexibility of production on substantially. 3D printing is here now. We are seeing, the 3D printed car has been made, but that kind of level of 3D printing hasn't moved into standard production at the moment. But I think, Adidas are using 3D printing on trainers, for instance, and certainly the aerospace industry is using 3D printing in components today. So we are seeing 3D printing happening. The advantage of that is it lowers waste, and also an interesting aspect, I think, for how factories will look in the future is that also they're much cleaner as well. So it's reducing waste, but also keeps the manufacturing site cleaner, which has implications on maintenance and also on health and safety. I've talked about the flexibility. I think the other thing is you can produce whole sections so that reduces assembly time and movement of products. So again, reducing your logistics costs and you're reducing your logistics times. The other interesting one of 3D printing is how it supports maintenance, in the fact that you could have a little manufacturing unit alongside a bigger factory that is there just printing spare parts that can be fitted on as they're required on the go. So this is where I move away from the enablers and start thinking about some of the implications. Before I do so, just check in, are there no more questions coming through?
No questions, but I think as we move into the implications for P&C insurance, I think you're going to start to get some questions. So right, okay. Nothing to date, but I think that was good background on the smart factory.
All right, thank you. So, some of the potential implications and these ones are looking in more generally than just in insurance, but they do have implications for insurance. So, fewer and more skilled workers. So that could lead to higher levels of unemployment, and it could lead to those exaggerations or exacerbating the inequalities that we see in society. I think this point about employment, there's an awful lot of publication around this at the moment. So if you wish to do research, there's plenty out there to read, and it isn't conclusive. I think the economists, the largest majority of economists, don't believe that the smart factory and automation is going to impact on employment levels dramatically. They think, as has happened in the past, that new forms of employment will be generated by the new technologies, and so that will absorb the unemployment levels which may be happening in factories. I think one of the implications from that, though, is that people's lifestyles, they have been changing over the last 20, 30, 40, 50 years, or since the Industrial Revolution, I guess. People's lives have been changing dramatically and generally moving to more a safer, lower risk working environment than would have been there in the past. And I think that would definitely be an implication from this, especially as we get into that limited or no interaction in production and logistics. Predictive and intelligence maintenance, I've talked about that a few times. So optimizing maintenance, reducing the number of instances, reducing maybe the time of those outages, and also reducing the associated costs with maintenance is almost certainly going to happen, and is happening already for some. And the next one, location footprints. For me, this is one of the interesting aspects, and I haven't actually read very much on this. So this is one of my views, and I'm happy to be challenged on it. Location footprints. I think the need to be near skilled workforce isn't going to be required. What will probably drive it is either where the raw materials are, where your primary power sources are, or actually being closer to the customer. So the location of factories, I think, could change, but also the size and scale of those factories. So on one hand, I think you could see us move to much bigger factories that really are quite vast and produce a huge range of products. But you could also see much more smaller localized factories using things like 3D printing that produce things much more direct for the customer, targeted at individual customers, and driven by the localized trends and requirements. So I think there's some interesting implications for both the location and size of factories. And so I've mentioned the scale of operations could change dramatically. I think energy optimization technologies, again, we're already seeing examples of this coming through. The power needs will change dramatically. In some ways, they might increase their requirements because with the level of automation, that's going to need an awful lot more power to support that. But at the same time, I think that's going to drive energy optimization even harder. With some of the smart technologies and the cognitive computing, you could see much more advanced techniques used to try and monitor and manage the use of power. So although I think the requirement of energy is going to go up, you might actually see levels drop. Design and go. So monitoring your operation live and using data to redesign autonomously. This is, again, this is a bit of my own personal view, but if everything is linked up in the way that I mentioned, then you can alter your designs, make those changes rapidly and move forward. So actually improving product quality and responding to customers' needs much more effectively.
There was a question, Luke, just as we reach the end of that slide. One of the questions that was submitted by one of our people earlier was, while the focus is on technology, do you think companies are losing traction with people skills and soft skills as an emerging risk? And so that, I was looking at that, kind of hints at your second point there on potential implications, that there could be no or limited human interaction in production and logistics. So just losing that human touch.
Yeah, I think this is a really interesting one, and there's a couple of ways to look at that. Yes, I guess one of the interesting things would be if there is a major outage, would we be able to go back and produce some of these things ourselves and not rely on the automated systems to deliver them? If baking was one I mentioned, I think so. Yes, you could definitely lose those skills, and there are some technologies I think today which, if we didn't have the automation, we wouldn't be able to produce. So that's definitely a case. But I think there's also there's some human knowledge and development that will take place in terms of the technical and computing skills will need to be increased greatly. And if we just think of we talk about having the cognitive computing and the algorithms, that does rely on quite advanced thinking and at the moment that thinking needs to come from a human being. So I think some skills will fall away, some new skills will rise, and and some of those could be really quite advanced. Does that address the question, Ian?
I think so. Yep. Okay.
So in terms of what we have today, just some of the examples of what is happening. So BMW, in terms of automating, are probably one of the more advanced that I've seen through the research I've done. The i3 plant in Leipzig is considered one of the most advanced. Predictive analytics, Volkswagen is already seeing 15% reduction in machine downtime as a consequence. And when I talked about the energy efficiency as well, the lower emissions coming through from Parker Water and Sanitation is one. And also in the first example from Siemens, where we talk about product defects, 15 defects per million. I mean, that is an incredible stat. If you've gone back, I was an engineer once. If you've gone back sort of like 20, 30 years, that is just way beyond what anybody thought would be possible at the time. So already we're seeing quite advanced advances and quite advanced activity taking place, but we're not at that level where all of these are being connected together and creating one really good example of a smart factory. I'm sure that will slowly creep and happen, but we are already seeing examples where this technology is being used today. So some of the potential limiting factors on the smart factory. So availability of availability of competent and capable resources is always going to be a key one. We talked about needing advanced thinking and development. These really are, some of these things really are at the forefront. So that is going to be a challenge in the short term. Funding. To be able to support this innovation, there is a lot of investment happening. Germany is doing that, but to really take these things on does require a substantial sum of investment, and those manufacturing facilities that have been operating for many years quite satisfactorily without even taking on some of the automation in the robotics, may find themselves slow to see the benefit of innovating in that way. I hope this doesn't happen, but competitive tendencies can restrict innovation at times. And if we don't address some of the big questions around things like liability, cyber, those could well be limiting factors as well. So moving to risk implications. I've mentioned the difficulties in determining liability of losses. So, if you're reliant on GPS systems, if you're reliant on a technology provider for communications, if you're reliant on a piece of code that's been produced by another company to inform decision making, if the wrong decision is made, who's going to be liable? Is it going to be the manufacturer or is it the supplier? So I think there's lots of questions to be answered. And I think this isn't just the case in the smart factory. There's an element of this when it comes to autonomous vehicles as well, and putting those on the road. And I know certainly if you take that case study, the UK government is looking at legislation to enable autonomous machines to take to the road. So there is probably a need for some judgments and consideration taking around the space. And I think, given the scale and speed at which technology this is changing, I think it's probably going to be, a learn and go. But there does need some consideration and thought. Using and securing data flows, this isn't going to work unless we can share that information between sites. So the means of maintaining that data, ensuring adequate communications. We all know, if we just think about our mobile phone, how intermittent that can be at the moment, but also our home Wi-Fi environments aren't always the most robust either. So making sure that those data flows are secured and that the communications companies can maintain a very high level of stability is another risk area. The vulnerability of cyber attacks, I think that's probably pretty clear to everybody. And the implications for product liability from cyber attacks is interesting. And this is, the cyber attacks are only going to get worse. And and we talked about, it's not just the criminal wanting to put in place some ransomware, or the young adult who's wanting to test his computing skills. Is also potentially the nations attacking nations, and industrial espionage as well. So protecting against those things is going to be essential. If we can't secure some of these manufacturing facilities, then I'm not sure we can really move to some of these smart technologies. Plus, it creates very interesting risks for insurers. It creates both an opportunity for ourselves, but it also creates the threat in terms of, at the moment, the losses associated with cyber are pretty difficult to determine. There isn't the loss history there to support it, and as events like the weekend happen, that's going to provide more insight. But equally, the speed at which cyber threats are changing means that it's going to be difficult to keep pace with that. Disruption and business interruption. I think there are some interesting aspects here as well. So whilst you'd expect there to be less downtime and unpredicted downtime, if there is downtime, there is a potential for that to become more severe. I mentioned that if the supply chain is connected through to the factories themselves, if that supply chain, a very early manufacture of a single part, is interrupted, that could have quite big ramifications further on down the line. So the accumulation risks here and the systemic threats that come through from this could grow. Changing labour requirements, I think we've covered that one. Keeping current and up to date. So obsolescence will become a major threat here. In order to compete, you're going to need to have some of these advanced technologies, and they may become obsolete relatively quickly. So actually, you could see like financial products coming onto the market to enable people to replace equipment on a routine and a regular basis, and that could enable some opportunities from the investment side. Increased product liability issues. As I mentioned, just through cyber, you could introduce a product defect that people aren't aware of, and that could have fairly big ramifications. Plus, if this is all autonomous and we're relying on a computer making a decision, if that computer makes a false decision, it may be some time before that error is picked up, and product defects could be introduced through that way, and again, those could have significant ramifications. Political conflicts is another potential risk implication from this. If one or two economies start to accelerate rapidly on this, like Germany, then that could create conflict between nations, and also if there's a disproportionate share of returns. So if one nation is seeming to take advantage of other nations through their pricing of particular technologies, then that could also lead to conflicts. And then the final one, the social tensions. So could we return to the Luddite movement? Again, Luddite is quite a UK concept, but these are the people that smashed up some of the early machinery that was introduced in the Industrial Revolution originally. If robots are really starting to take over human jobs at a pace, then you could always see that there could be some social tension as we go through that. Again, that would have some interesting ramifications, not just in terms of losses incurred, but also maybe like the protectionism that might introduce into the different economies, and the as we're seeing a level of protectionism coming through today. Cyber risk. So I kind of feel like I've covered this through the conversations we've had already. I think these are some interesting slides. I think the first one, or some interesting charts. The first one really highlights the number of vulnerabilities, whether that be an operator who's monitoring the plant, whether it's the programs that go into that and the programmer that introduces defects. The cage, so if it's all bound and all protected, could that introduce issues? The control of the actual robot itself, and the robot, and then in terms of the work piece, where we're actually talking about, I guess, the logistics and the flow, I think, from that particular point. But also the sensors. So, it may not be just hacking computers, but just actually taking control of a sensor or monitoring a sensor. So again, we talk about industrial espionage. If you can hack in, use somebody's cameras to see how they're manufacturing specific parts, that is quite an advanced level of industrial espionage. So some interesting implications coming through from there. As I mentioned earlier, that does create threats and opportunities for ourselves. But it's those major systemic risks which have real implications. So changing patterns, insurance risk. So the changing risks associated with the changing technology and the socio-political implications could see radical shifts with implications for our insurance markets. One, again, we've touched on is health and safety claims and injury. So if there are less occurrences of injury within the workplace, that will have implications for some of the insurance products distributed around the world. That again, that could be positive and negative. One of the things I kind of reflected on a little bit as I was putting this slide together is the presentation that you had last time from Trove, and the just-in-time kind of insurance kind of concept. They could see environments here where if you have a factory that doesn't have any people operating within it, maybe they don't have this type of cover. As soon as somebody enters the factory, maybe that cover is turned on. So thinking about how all of these things connect together is quite interesting. Less public liability claims. So again, health and safety. If people around the factories, especially if factories are moved to more remote locations, or collected together in more remote locations, then public liability issues could be lower. But also in terms of automating the logistics side, it could also reduce public liability claims. Downtime, maybe less, but loss is greater. So I mentioned this earlier, where it could be quite a small change for issue further up the supply chain could have issues further on down. Or, if something does go dramatically wrong, if there is a particular piece of software that fails, that could be failing in a number of different factories and could have creates quite systemic issues across. Also, if there's communication issues or the GPS systems go down, that could have quite significant ramifications as well. So whilst downtime is probably going to reduce, my expectation is that actually the events, when they do happen, could probably be more severe and bigger, and therefore have greater losses associated with them. And again, the challenge for us is keeping abreast of this, the changing loss history, and being able to predict forward-looking what some of these more systemic issues could be if they were to arise. Major physical losses when something go wrong. So, the expectation again would be that the risk of fire and flood and theft would be reduced by having things like smart sensors. You'd expect security to enhance, so thefts might be lower. That's not just in the factory, but also in the supply chain or in the logistics. Flood, monitoring ingress of water more efficiently should mean a speedier response and hopefully less impact from that. And equally, the risk of fire you would expect to reduce from the number of sensors. But also things like if the factories do become cleaner environments, then there may be less materials to spark fire. Plus, more controlled manufacturing techniques again around flammable materials could maybe reduce the incidence of fire in those or explosion in those environments. So maybe some of the traditional losses may be reduced. However, again, if there was fire to happen or a major flood, then actually you'd expect the rebuild and replacement costs to be increased because the level of technology will make that so much more expensive. Although occurrence may reduce, the actual events could be much bigger. Again, this is a supposition on my part. And accidental damage, again, with autonomous vehicles and robots operating around each other, there is a potential to reduce a number of accidental damage situations. One thing I meant to highlight earlier in one of the slides was what's currently seen as one of the big problem areas is human and robot interaction. So there have been a number of unfortunate cases over the last couple of years where the humans have been killed or seriously injured through robots, and it tends to it tends to be through those interactions. But actually, the next stage of these advancements with sensors is to make sure that doesn't happen. But equally, that those sensors could be used to ensure that there is less risk of contact between the robots themselves and the autonomous vehicles. So hopefully, accidental damage is one that you'd expect to see reduce. Ian, I think there is a question.
I don't know. Nothing's come in here.
Okay.
But maybe I can throw it back to people in terms of the pattern of insured risks that Luke has identified here. Is there anything missing, or do people have comments on some of the more important of these? Is this the full and complete list, or are others? Do you have ideas about other things that maybe would appear on the list? So let's just give a second to see if anybody has comments, questions on that, and if not, then we'll move on. Okay, I don't think, no questions, Luke, so let's go on.
Sorry, it took me a moment to unmute there.
Yep, no problem at all.
Right, so the next slide, product implications. So product liability and recall. So again, without wanting to repeat myself from some of the earlier ones, autonomous machines, you would expect to see that increase quality and reduce accidental damage. But also, actually, and this is again another aspect I didn't touch on earlier, the autonomous machines could be doing the QA activities, and they could be doing those at a level which we don't currently see. There's no reasons why machines couldn't be doing this almost at a molecular level. Again, that's quite advanced technology, probably wouldn't happen at the moment. But in space, for travel, for instance, that could certainly be useful. But my point is that machines can do a level of QA which is much more precise and much more specific than we could probably do today, and that could make quite big advances. Plus, not only could the autonomous robot do the QA activity and review the quality of a part, if you need any adjustments, they could potentially do that too in real time without any human interaction being needed. So maybe an engine has isn't quite as smooth as it should be, then it could polish down certain surfaces. So some interesting implications of how all this interacts together. But as I mentioned, cyber threats could introduce product defects if not properly protected. Workers' compensation could well reduce as factory workforce reduces. General liability claims, I'd expect that to probably be relatively neutral, but the claims may become less common. But again, time will tell on that one. If there's any views from around the telephone, that'd be interesting. Professional liability, that is one where you expect to see significant increases. The judgments that will be taken by a small number of professionals that will have big implications for a number of different factories is going to be substantial. So you'd expect professional liability to increase dramatically, certainly in terms of the potential liabilities, but also maybe in the interest and desire for such products. Contingent business interruption and standard business interruption. Already mentioned the frequency of losses could change, and the loss history will change. On one level, you may see the need for this reducing, but actually, again, I think given the replacement cost of the equipment, I would expect the market to stay pretty strong and people to see this as pretty essential. Although pricing competitively is probably would be a key point for this, I would think, as it will be for a number of these. Accidental loss, you'd expect those to decrease. High value concentration losses, new specialist forms of concentration risk are almost certainly going to appear that we haven't considered today, and how those would arise and where they come from will be interesting. Cyber coverage. Cyber coverage is still in its infancy, really, and I think some of the cyber exclusions that have been introduced are probably adequate today, but you wonder if that will change in time. I think this is one of the places where public perception of what's acceptable and isn't acceptable will change over time, and I think coverage in terms of insurance needs will definitely change and morph and be quite dramatic, but equally, how cyber is linked to other insurance products, I think will also change. But again, time will tell. Traditional property, fire theft, again, you would expect that to reduce. One of the another aspect which I meant to touch on, when we talk about maintenance, one of the things I think is interesting from a connected factory, and I might be going on to something I'm going to talk about in the next few slides, but one of the interesting implications I think for insurers is actually how we connect in to the smart factory. Can we utilize the smart sensors to help us monitor incidents and coverage? Can we analyze the computers that are designing these factories and maybe analyze what equipment we have? Could we use sensors to tell whether a piece of equipment has gone down or a factory has gone down? And can we alter our cover for those scenarios? If somebody adds in a whole load of new equipment, could we be automatically notified of that as it arises and change our covers accordingly, almost in real time? I think there's some really interesting dynamics there, and how the smart factory, especially the sensors, are utilized by the insurers to aid like the sales process, but then also to monitor on the claim side. So if we do know there's a flood there, as insurers, maybe we can do more to respond to that flood, and do so using autonomous machines ourselves that are held within the factories to help us respond and reduce the losses by responding quickly and addressing the issue rapidly. So, and then if you get into that kind of environment where maybe we do have a robot in some of these bigger factories, if we did get large, massive factories, maybe it would make sense for a insurer to have robots on site. Then does that open up other opportunities for us? Actually, does it open up the opportunity for us to become the maintenance experts that are helping to manage those sites? You wouldn't expect that to be something an insurer would do, but I'm just thinking about the art of the possible and how this all connects in, and what role the insurer looks to play in the smart factory in the future. I don't know if that point raises any queries with the people or comments.
We'll just give that a second, and if people have questions, do fire them in. But if not, then we will move on.
So, in terms of implications for, claims experience and reserving. So, as mentioned above, the rapidly changing nature of the risks and the products will also have implications for our claims experience, and being able to build up the claims experience rapidly will be key, but also predicting that and using maybe some of the cognitive computing techniques to actually help us predict like claims experience or claims events will be potentially key to this. Again, if we're linked in and we're able to use the data, then we could be using that for our own analytics around potential claims in the future. The role of experienced underwriters, I think, will actually become even more important and become greater, but there'll probably be fewer of those experienced underwriters, and that was both in terms of inception of the risk, but also then monitoring the risks on an ongoing basis. And I've mentioned the thing about using autonomous machines for site inspections. And I've also mentioned the connected insurer. So I have got ahead of myself. So apologies for that. But I think using those on-site sensors is the key there. Solving the liability conundrum, that's got to be key for us. As with autonomous vehicles, the question over liability is key. Pricing. So using the big data to help us inform pricing, looking for new rating factors, and we can do that almost in a dynamic way. Again, this relies on us receiving data from our customers, but there's no reason why we couldn't be pricing dynamically. By that, I mean, again, if something changes in the factory, the parameter changes, then maybe we could change the price, but also monitoring incidents and events, and incidents that maybe don't result in an insurable claim, but are still because of the magnitude, but still an insurable loss. That could also help inform that dynamic pricing and looking forward to what could happen. In terms of responding to claims, again, if we utilize autonomous machines ourselves within factories or within local areas, then that definitely is something where we could increase the speed and response and accuracy of those responses, and that could be very powerful for our customers, not just in terms of providing a rapid response from an insurance perspective and faster fulfillment of a claim. It also means that we can, we're actually improving their environment and giving them, for instance, less downtime if we were providing robots that could respond to some of the threats rapidly. So there's some interesting applications there and interesting thoughts. The traditional risks are probably going to become less important, but there are other risks, I think, which will come through, which will replace those. Automated payment systems and automated logistics could make fulfillment much quicker. So the smart factory, if it can produce things flexibly, and as their customer need and to meet customer needs, that means that actually we could fulfill much quicker too in terms of our supply chain supporting us. If there's a piece of kit if there's a need to replace a particular robot in a factory, maybe that robot could be sourced much more rapidly and quickly than we can today, and in a much cheaper way for us. But also in terms of payment systems, fulfilling payments to both in terms of paying out on claims, but also receiving payments back from factories. We talked about just-in-time kind of insurance products where they fluctuate and change. The payment systems could be automated too, that mean that actually receive payment as those things change. So now there are opportunities for insurers to provide broader services. I think historically, when you look at the insurance market, when we've tried to provide broader services, that hasn't always been the most effective, and we've moved back to our core competencies, but certainly it's something worth thinking about. And finally, I think I've covered quicker than I intended, insurance as an enabler. So, we always talk about, when we talk about things, we tend to think about the loss side of things and what it means from a pure insurance risk perspective. But as always, insurance itself can be an enabler for some of these technologies. And I think I wanted to take a moment just to reflect on that. And if we think about human endeavor in the past, whether that be the first explorers that went out into the world, or whether we're talking about the first space travel, insurance has been a part of that process and provided the cover which has given some financial stability to those people that have innovated or explored and pushed the boundaries. And and there's no reason why insurance can't be at the forefront of that now, and develop cover that's provided and enables capital investment and supports smart factories in moving forward. With technological developments and the new perils, we do have the financial strength to help provide that financial stability, but also in terms of the way that we've supported industry over the last 100 years or however far we wish to go back, fire safety systems and security systems is something that the insurance industry has definitely given some impetus to through the risk inspections and the contractual clauses that we've put in place. And again, there's no reason why the insurance sector can't help drive some of these advances forward in terms of thinking about how sites are secured and protected. And that's the insurance side, and insurance being an enabler. But equally, we tend to have capital to invest, and investment returns have been light because of the low interest rate environment. So actually, investing some of the alternative investment options could be attractive. So providing that investment capital to innovative environments, as we have been seeing in the renewable energy sector for some organisations, we could see investment being positively provided to enable technologies in the smart factory. Is there any questions on that?
Do people have questions? Fire them in to me, and I'll pose them on to Luke. And all of your questions are submitted in confidence. Don't worry about that. So, Look, if people do have questions, maybe I can invite them to send the questions to you following this broadcast. That they will be receiving a copy of the slides, and they're fairly text heavy. So as they take the time to go through the slides, and if they have questions, perhaps they could email you directly and copy me, and so I could be banking some of the responses and send those back to members if there's a lot of questions that do come after the fact for you.
Yep, and happy to do that. That's very happy to respond. So that's and concludes the presentation. So thank you. I hope that was useful, insightful, and gave useful background to the smart factory, and enables to understand and think about some of the implications for us as a sector. But any insights or questions people have now will be welcomely received.
Question I have for you, Luke. We talked earlier in the intro about this year's main topic is autonomous vehicles. What's next for the CRO forum? What's next?
We haven't set the topic for next year. Autonomous vehicles is very much the topic for this year, as we mentioned, and I think that's in the early stages. I talked about the mining example. That's one that's definitely been considered and thought about. We've also, had some insights from the robotics sector in terms of in this environment, it's more like retail robots and personalization of robots and how that is likely to support the retail environment. So so thinking, when we think about autonomous machines, we're trying to think about very much the different sectors that could be impacted, rather than focusing maybe on the smart factory itself. And I think I'm hoping that it will be quite an insightful publication when we produce it, with it's such a broad topic. There are so many different aspects to consider.
Okay, and I haven't received any other questions, Luke, so I'm going to thank you for your presentation. Very informative, and it's a snapshot of the challenges our industry faces with the onset of new technologies, and we appreciate you finding the time to join us here today from the UK. Very, very much appreciated. As noted earlier, a copy of Luke's slide presentation will be posted on our website under the Risk Officers Forum tab. Webinar participants are going to be asked to complete a brief follow-up satisfaction survey you're going to get from I'll send you a link through SurveyMonkey, and your feedback will help to enhance the quality of future broadcasts and also help point us to topics of interest to members for future emerging risks webinars. We invite your thoughts on speakers and subject matter. And before I sign off, if we could flip to the final slide, I wanted to alert everyone to our next event, and that is our second Risk Officers Forum meeting of the year. That takes place on Wednesday, September 27th from noon till 4 o'clock. Our guest speaker is Lapo Calame, Director, Catastrophe Risk and Economic Analysis with the Insurance Bureau of Canada. Lapo is going to be speaking to us about earthquake risk as the keynote, and we're going to ask you to please circle this date in your calendars. A reminder note with the registration form will be issued to stakeholders a little closer to the event. Our final Emerging Risks webinar is taking place in late October, and we're going to have David Coletto, CEO and co-founder of Abacus Data, speak to us about demographics and generational change and the implications for property and casualty insurance. And he's a bit of a futurist and an expert on millennials and their behavior. So I think you're going to find his presentation quite fascinating. And if you go to abacusdata.com, you'll get information about David. He looks like he's about 15. Quite an interesting speaker, and tenured prof, a PhD at the University of Ottawa. So he's going to be a delightful speaker. I want to thank Tracy Cook and her colleagues at EventStream Inc. for their technical support with today's broadcast. This concludes today's webinar. We look forward to having you join us for future sessions. Thank you again for tuning us in, and goodbye for now.